Yeah, awesome to be here, first off. It's pretty, I can almost not see anything, but from what I can see here, it's pretty crowded, so thanks, man. So what you can see up here is actually, I wanted to start this talk with some examples of Mother Nature, because what Mother Nature gives us is sometimes so impressive. For example, the Romanesco broccoli just looks super amazing. So this is basically a cone shape, and the surface of this cone just has a lot more cones, and this just keeps on going and going. If we look at lightning, we can see that it bursts in every direction that it can find because it's looking for the path of the least resistance. If we look at a nautilus, we can see a natural example of a logarithmic spiral. And if we look at a tree, we can see that it has so many secondary branches that we actually fail to count them. And all these things have one thing in common. They are what we call fractals. And because there are fractals, they look super impressive. So who am I? My name is Gregor Adams. I'm from Germany and currently moving to the States, so yay! I'm totally into art, music, and some might know that I'm pretty crazy about CSS. So today I'm going to be exploring fractals with CSS. And just a short reminder, just a short note, the pictures in the background you can see, all these images have been generated with CSS, so they're actually based on the fractal logic that I have been creating in the last month. So basically, what is a fractal? I get this text from Wikipedia. So basically, a fractal is a natural phenomenon. That's basically what we saw in the pictures before. And it furthermore is a mathematical set that exhibits a repeating pattern. So this tells us due to math or with the help of math, we can actually create fractals. There's one other thing about fractals. So if it's the same at every scale, it is called a self-similar pattern. And there's some differences with fractals. Some are self-similar, some change the pattern at different scales. A very good example for a fractal that does change the appearance at different scales is the Mandelbrot set. It's also probably my favorite fractal because of the size it actually has. The fundaments have actually existed since 1902. The Mandelbrot set did not get that popular until in 1980. Benoit Mandelbrot actually released a study. And since that day, it is actually named after him. And some of my slides do have these links here. So they will open up a page. This one goes to Rosetta Code. Rosetta Code is basically it's like Wikipedia, but you can put algorithms in different coding languages. And what I did is I implemented the Mandelbrot algorithm in SCSS. And it's also now on, you can actually find it on that link. So for this talk especially, I decided to do something different. Every single demo that I have for you is going to be compiled live in the browser. So sometimes it might take a while. Sometimes they might not work. I'm not entirely sure. I've been working for a month on this. And sadly, I didn't really have time to practice. So let's just hope this works as I want. So yeah, basically, Mandelbrot algorithm in SAS. This is already like, OK. Let me just get this a little smaller. So basically, this is the entire algorithm. I'm not going to go into it in detail because I basically don't have the time. But what I'm doing here, I'm live compiling the Mandelbrot algorithm on one element with box shadows. And just to show, whoops, that was not supposed to happen. So what I can also do is, instead of doing this in grayscale, I could also do this in color. And this is going to take a while because it's being live. Thanks to Ellipsis, I can now actually do this in the browser. That's pretty exciting. So what I can also do is I could say I can zoom into this. And the further I zoom, the more detail I get. So if I would say I go to 0.5, I can see actually this black spot, and what it actually is it's the next Mandelbrot lake. So I can change a few properties in here, and this is going to zoom into exactly that spot. So what I'm doing is I'm adding some iterations and some more zoom, and then I'm just relocating the zoom point. And it should change. If you, yeah, so this is a zoom of, what is it, 600 to actually display this. And this is pretty nice. But actually, Fractals started a lot earlier than the Mandelbrot set. So the first guy to actually implement a fractal was Georg Cantor. He's a German mathematician, and he's basically the inventor of the set theory, which is a fundamental theory in mathematics. And he introduced the Cantor set in 1883. So his example was just basically a line. What he did is he split it in 3 parts and just removed the middle part. And then he kept going and going. And basically what happened is this blew his mind, because he was like, okay, so I have an infinite number of lines, each with an infinite number of points, and he didn't get it. So he actually checked into a sanitarium, because he did. Not only because of those reasons, basically because the people were like, you're crazy, this can't be happening. So yeah, he checked in and he figured out he was not crazy, so. Another very famous mathematician was Helge Koch, and he actually made one of the most famous fractals. It's the Koch snowflake, and it's based on the Koch curve. And this is actually a fun one. So what this does is, in the beginning, we have just a simple line. You might not see it because it's just going to be a small white line on the bottom. Yeah, you're not going to see it. So what Helge Koch did, instead of removing lines, he added lines. So he said he's going to split the line into 3 parts. And then he's going to take the middle part and rotate it by 60 degrees and then just connect the gap. And the more iterations he used, the more detail he got. So maybe let's just go one step back. So each side is going to get the triangle, and this just keeps repeating. What we can also do with this logic is, if we were to say, for example, we want to shift the coordinates of the triangle. Let's say we move this over here, and then take some more iterations. Then we're actually replicating this shape. So the deeper we go, the more detail we're going to get. And this, we can go really crazy on this. So the flatter we make it, it kind of looks like a terrain or surface or something. And the higher we go, the more it's going to look like a star, maybe. Fourth person, yeah, he seems to be funny. I love this picture. I actually do love his pictures. His name is Michael Barnsley. He's actually what he did, he founded a corporation which is basically just about fractals. And he's really big on the iterated function system. What he did is he implemented the Barnsley fern, which obviously I also implemented in SAS. Yay. So basically what this does is it takes random numbers and then runs a few algorithms. And depending on what the random number is, it just positions the dot on a certain spot. The more iterations I run, and this might all take a little, the more detail I'm going to get. Exactly. I've done this one with Ruby SAS with 100,000 iterations, and it took 2.5 hours to compile. I haven't tested it on libsas yet. So also, like, the only reason I'm able to do this is because libsas 3.5 shipped. So thanks to all the SAS people. So there are basically two different systems to draw fractals. It's the iterative function system and the Lindenmayer system. The iterative function system is basically the system that's used to draw Mandelbrot set. You can also draw a Sierpinski triangle or, for example, the Barnsley fern. The Lindenmayer system is a little different. It's, for example, the Koch snowflake is a really good example for the Lindenmayer system. Another good example is, okay, so I figured this might happen because the screen is so small. Let me just see if I can get this smaller. Yeah. So the Sierpinski triangle, basically what we're doing is we're starting with a triangle, and then on the sides, we're just adding a new triangle. And there are different ways of drawing this. So you could draw this from the inside out, what I'm currently doing, or you could draw from the outside inwards. So if you know about fractals and you're like, this is not correct, this is correct, trust me. So the deeper we nest this, the more detail we're going to get. And we can just keep on going and going. And with all the alt system stuff that I'm doing, the nice thing is the more HTML, the more DOM I'm taking, the more detail I'm getting. And the CSS is never being changed. So here's another one, just also gonna make it a little smaller. Yeah. So here's another example of an L shape, and if we nest this, we basically get a lot of L-shapes that just wrap around and fill the space. And we keep repeating this over and over again. By the way, these slides are already online, and they're online with the live editor, so later you can actually play with this online. And I've done a few things. This is just something I came up with. So you can, with the alt system, you can really easily draw really nice repeating patterns. So this is another example. The deeper we go on this, the more detail we're going to get. And I just put this in here so later people can actually play with it. Here's another pretty fractal. That's basically just a bunch of circles. And what I'm doing is positioning the circles on the border. And then keep repeating that. So now the funny thing is, on this example, if I take 3 circles, so I leave 1 out, and keep doing that. And then the next thing I would do is, well, let's actually keep it like this. So now if I take a lot of these elements, we're going to see a shape that we have seen before. And this is actually the Sierpinski triangle. And Sierpinski triangle, that's why I said there's so many ways of drawing this. It has appeared to me like in so many things that I've done, I wanted to do something totally different, and I keep getting this shape. So I kind of got like the idea how Sierpinski originally got the shape, because he basically what he did is he took like 4 squares and just deleted one, and that he keeps going, and the shape just appears. So it's actually pretty funny. I realized that like I've been doing fractals quite a while, and just realized that like 2 or 3 months ago. So I was like, okay, that's how it works. We can actually do pretty artistic stuff with the L system. So I think you might not see this in detail. What I'm actually doing on this, I'm kind of tricking the browser. So this thing is super huge, and then I'm downscaling it so I can get more detail on this. And what we can also do is take the fractals into the 3rd dimension. This is, I think I did this example last week. So this is especially for Cascadia. I think on my last talk I was asked if I had ever done 3D stuff, and I mentioned that I had done 3D stuff with fractals, but it's just basically the problem with these super complex things in 3D is that it just takes a lot of DOM. And it's really hard to nest. I think if I were to nest this one deeper, basically the rendering would totally fail, and it would just crash the browser. So sadly, we're kind of limited to that. And then, yeah, we can also just take shapes, and repeating the shapes, for example, taking a pentagon and repeating that over and over again, we actually get taking a pentagram, we actually get a pentagon. And we can do this with other shapes. So if this were a hexagon, it would end in a hexagon shape, and so on and so on. With all that logic, what I did, and all these slides, like I said, they are generated with CSS, and all the slides have this link on the bottom, so you can actually click this later and look at this on CodePen. So I'm just going to look through all these examples so you can see what I have generated with CSS. I would have loved to put these on like live, but they're like super heavy, and they would definitely crash the slides, so I can't do that. So as you can see, for example, in this example, we can do some really, really funky stuff, and it actually doesn't really look like CSS anymore. It's more like as if it were done in Photoshop. And the fun thing about this is that the code is super, super compact. It's super easy to maintain these things, and it's super easy to just get new ideas doing this. This one I really like because it kind of looks like you were falling into this cave or something. So I have 7 minutes left. I have 2 things that I want to show you. Basically, there's one thing. This is basically how I started doing fractals. So in the beginning, I basically had one branch of a few elements that I would just position on top of each other and then rotate. And so let's start differently. Let's do it like this. Come on. Okay, I'm sorry. So basically what I did is, basically in the beginning I had one branch. And to not have to duplicate this, I figured I need some logic to actually, from this branch, display the entire tree. And luckily, WebKit implemented something a few years ago, which is what is called WebKit box free flag. And just by adding this property, I'm now able to just take the element and mirror them. And while I mirror this, all the children are also mirrored, so I just get this super big fractal. I started doing this, and then obviously I started doing animations with this. So I put some simple animation on this, and I get. Let's make this a little slower, maybe. So basically, I got all these awesome shapes, and So the next thing I did is I said, depending on how deep the nesting is, I want to actually change the background color. So I was able to do something like that. And then the next thing I did was say, depending on the depth, I want to actually put some delay and change the duration of the different elements. So I said, okay, let's just change that. And this led me to something that actually created these kaleidoscopic visuals. So what I did after that is actually think about, and I got this idea from the JSConf in Berlin because this friend of mine actually held a talk. And he did some audio visualization, so I was like, okay, I kind of have to combine that. So I sat together with him and basically implemented this audio visualizer that is now, this is also on CodePen, and what I did because of the cross-content policy on Chrome, I'm now adding, I added the local audio stuff, so you can just take any local audio and you can just put it in, and I basically have no idea what song this is. So let's just play it.
Yeah, we don't want to do anything to scare your children. That's the last thing we want to do. We don't want to scare anybody.
Oh my God!
Yeah, so I hope you were able to see that. If you didn't see that because it's, the contrast is not big enough, just look at it online. You can see, so this is the URL. So it's slides.pixelass.com/CascadiaFest 2015. And another thing you might want to look at is this link down here. It's just a link to a collection. I think I have like 50, 60-ish fractals. Some of the examples you saw, and yeah, it's basically a lot more. And also make sure to follow me on Twitter. I'm at GREGOR because I didn't get the @pixelass handle, but on CodePen and GitHub, you can just find me under pixelass. Thanks.